All right, guys, welcome back. All right, we're ready? I know we don't want to do it, but we must. Okay, so take a look at your notes for today. Okay, if you can remember back from December, okay, long ago before Christmas break, you learned how to do a first derivative test. And then do you remember that we did graphs of derivatives? So now we're going to apply that to sort of a physics scene, if you will. So if you haven't taken physics, it's okay. I'm going to do my best to draw all those topics in as if you haven't taken it. But if you have taken physics, today should be a little bit easier. So we're going to start off with all of our functions are going to be position functions. Okay, so your position function is going to represent a directional distance from an origin. When I say directional, what I mean is positive or negative. So if you are moving up and down, okay, positive would be up, down would be negative. Or you could also be moving left, right. Positive would be to the right on a number line, and then negative would be to the left. Okay, for your notes today, the position function is almost always going to be x of t. But some textbooks will use h of t, usually if it's like a height function, like you're throwing something in there. Okay, then if your object is in motion, we are going to restrict time so that it's only greater than or equal to 0. Okay, so we're going to pretend that time can never go backwards into the negatives. It's always going to be 0 and up. Okay, so take a look at your first question. It says we have a baseball that is thrown in the air so that its position is given by this function right here. Okay, so the first thing that I want you to do is with algebra to try to find some of the features that I have listed there below. So without any help, you should be able to find x and y intercepts and relative mins and maxes. Now, because it's the Tuesday after Christmas break, we will do it together, but you should be able to do this. The first thing we're going to find are x-intercepts. And remember that if you're looking for an x-intercept, you're going to set the equation equal to 0. That is how you find an x-intercept, is you take whatever the equation is, set it equal to 0. So let's go ahead and do that. So I have negative t squared plus 14t plus 32 equal to 0. Now, there's a little bit of an issue with that equation. We know we're going to need to factor, but why can we not factor this as is? Yeah, you can't have a negative on your t squared. So we're going to GCF that out. So my t squared will be positive, which means my 14 is now going to be a negative. Same for my 32. And now I'm looking for numbers that when I factor will multiply to 32 and that will subtract to 14. So what would times to 32 and subtract to 14? 8 and 4 will add to 12, but we need 14. I thought I heard another pair. 16 and 2, good. Okay, and then when I place the negative, I'm going to put it on the 16 because I need the 14 to come out to be minus. So my factors are going to be t minus 16 and t plus 2. Which means that my x-intercepts or my solutions are going to be what numbers if t is with a minus 16? positive 16, and then the other one will be t equals negative 2. Okay, so let's just kind of set up our graph now. Okay, so let's do it over here to the side. So we know that our graph touches the x-axis at, we'll say negative 2 is here, and then we'll say 16 is over here. Okay, now, can anyone tell me what shape this graph is going to be if it's a negative t squared graph? Down what shape though? A little rainbow, yeah, quadratic, a parabola, whatever. So go ahead, and when you draw it, I want you to start off with a dotted line, and then once you hit here, I want you to go to a solid line. Why would I have everything over here with a dotted line? What did we say about time? Only greater than or equal to 0. So this part of the graph is there, but it would not be included in the model because it doesn't make sense for time to be negative. Okay, so we found our x-intercepts. Next thing we need is our y-intercept. Okay, think back. How do you find a y-intercept? What would you need to do? Plug in 0 for the x. Very good. So for my y-intercept, I'm going to let my x equal 0 and plug it in. So my equation was negative t squared plus 14t plus 32. Now it's 0 squared plus 14 times 0 plus 32. And what is that going to be? When you just do the math on it, 32 is correct. So what that means is that this dot here is 0, 32. And then this is 16, 0. Okay. One other feature we're asked to find is the min or max. And for a min or max, you learned how to find this semester 1. Do you remember we take the derivative and set it equal to 0? You remember that to find a min or max? Okay, so let's go ahead and do that now. So for our min or max, we're going to take the derivative and then set it equal to 0. What would the derivative of that equation be? Looking at this guy right here. Negative 2t plus 14. And then what happens to the plus 32 when I take the derivative? Okay, goes to 0 and then equals 0. What can we take out of both of those? Negative 2. That's going to leave me with a t minus 7. Which means that where is the flat spot on my graph going to happen at? What t value here? 7. Very good. Now, someone in the other class had said, doesn't it have to be in the middle exactly? Yes, it does. If you remembered that, you could have found it that way. Okay, so all of this kind of stuff you should already be able to do. So let's go through what each of these features represents. The y-intercept in the model, what would this refer to? Remember, baseball, we're throwing it in the air, then it hits the ground. What would the 32 represent? What? Be bold. Okay, the height in your hand, sure, or the initial height, because it's the height at the beginning. So I'm going to put right here, this is the starting height of the baseball. Okay, now obviously 32 feet, there must be standing on a ladder or something. Doesn't really make sense, but it's fine. Okay, so the starting height of the baseball is 32 feet. Now let's talk about this x-intercept. What would this represent when it hits the ground? Very good. Okay, so at 16, this is when the baseball hits the ground. And that would also be the end of the model. Okay, we know that once the baseball hits the ground, it doesn't keep shooting through the earth. Okay, that wouldn't make any sense. So at 16 seconds, we would no longer use this parabola to model that behavior. Okay, then last thing, the max or min, That would be just the highest point of the ball. Okay. So all of those things, just kind of keep them in your mind. You should have done questions like this in Algebra 2, maybe a little in pre-cal. Now let's get into the calculus part of it. So if you take the derivative of the position function, remember that a derivative tells you how fast that thing is changing. So do you remember like dr dt was how fast the radius was changing? dv dt is how fast volume is changing. So the derivative of position would be how fast your position is changing, and we call that velocity. So when you take the derivative of a position function, we're going to call that velocity or v of t. Okay, velocity or v of t. And velocity tells you the direction that your object is moving. So if your velocity is greater than 0, you're moving in the positive direction. Now, depending on which axis you're on, that could be up or it could be to the right. If your velocity is less than 0, that tells you that your object is moving in the negative direction, which would either be down or to the left. If your velocity is equal to 0, you would say that your object is at rest. And so if your object is at rest, that means that it is not moving in that instant. Now, the reason your at rest points are important is that those are the only places that your object could potentially change direction. And so I want you to think about, you remember last semester, when we took the derivative and set it equal to 0, we always called those critical numbers. So your at rest and your critical numbers, those are the same thing, okay? So it says, find the ball's velocity at any time. Remember that velocity means that I'm going to take the derivative of position. And I already did that. So v of t is negative 2t plus 14. Okay, notice I'm just kind of copying the work from up here. We knew how to take the derivative already, but now we know we're going to call that velocity. Okay, then it's going to ask me for the velocity at 3 different times. First, it's going to ask for the initial velocity. What time does initial imply? Time 0. Very good. So you're going to plug that in. Anytime it says initial, that means at the beginning of the model, which would be at 0. So if I plug in a 0 here, v of 0 equals, that'd be negative 2 times 0 plus 14. What would that come out to be as an answer? 14. Now, I'm going to put a positive in front of that, and here's why. Remember that the positive tells me something. It tells me it was traveling up, versus a negative would have told me that it would have been traveling down. So it says to interpret in the context of the problem. So I'm going to show you what I mean by that. At time t equals 0, the ball is traveling 14 feet per second up. Okay, at time 0, the ball would have been going 14 feet per second in the up direction. Okay, which makes sense because the ball was thrown up with that initial velocity. Okay. Now let's skip ahead to right below that, and we're going to find the ball's speed at time 10. Okay, so change the 5 to a 10. So I would find the velocity at 10 equals negative 2 times 10 plus 14. Notice I'm still taking my time. I'm still plugging it into my velocity equation. What is negative 2 times 10? And what is negative 20 plus 14? Negative 6. Now, that is the velocity. But the question is asking you for what? Speed. So here's the difference. Velocity, this is kind of a physicsy thing, but it's written right here for you. Velocity tells you how fast and what direction. Speed only tells you how fast. So in this case, if -6 is my velocity, what would my speed still be? Just the 6. So the speed is 6 feet per second, but the velocity is -6. And what is the negative add to the information that I have? That it's traveling in a downward direction. Very good. So that would be at time t equals 10. The ball is traveling 6 feet per second down. Okay, so at 10 seconds, the ball is traveling down at a speed of 6 feet per second. So remember, velocity can be plus or minus, but speed, you disregard the plus or minus and just keep the number. Okay, are we doing okay so far? Turn the page. All right, so typically on the AP test, they're not going to give you any like throw up, throw down type of problems because you can use like physics equations to solve them. So typically they're just going to give you like a scenario. So here it says we have a particle traveling along the y-axis from 0 to 6. And then it gives us its position equation right here. Okay, so part A says find the velocity. If I have position, how do I find velocity? Very good. So if this is position, v of t is going to be the derivative of that. What will the derivative be of that position function? Okay, very good. So to get from position to velocity, I take the derivative. Then it says to find when the particle is at rest. What do I do for at rest? Okay, am I plugging in 0 or setting equal to 0? Setting equal to 0. So remember that at rest means that I'm going to set velocity equal to 0. Okay, is there anything that I could factor out of that equation as I do this? Okay, 3 comes out, that's a t squared. 12 divided by 3, that's a 4t. 9 divided by 3 is a 3. And then I need numbers that are going to multiply to AC would be a 3 and add to 4. So what numbers would I want for my multiplication to 3? 1 and 3 are my only options, but they would have to both be negative to give me the -4 at the bottom. So it's going to be 0 equals t minus 1, t minus 3. Which means when is my particle at rest? At what time values? 1 and 3, very good. Now, quick little note, you may forget this, but on your delta math, when we get to it, let's say that your answers are 1 and -3. Would you type in -3 as an answer? No, because remember, for time, when does it start? 0. So if you get any negative answers for time in your homework, you would not type those in. Okay, then it says, when is the particle traveling up? You're going to do a first derivative test. First derivative test. So let's review how to do that. Remember, your at rest are basically your critical numbers. So 1 and 3 are going to go on your number line. And then you're going to pick a number bigger than 3. And remember, you're plugging back into this to see how it comes out. If it's like a plus or a minus. So number bigger than 3, let's say we pick 4. 4 minus 3 is? 4 minus 1 is? And 3 is also positive. So plus, plus, plus. Overall, that's a big plus, which means my particle was traveling up. Between 1 and 3, what could I pick? 2 is good. What's 2 minus 3? 2 minus 1. And then 3 is also positive. So it's plus, plus, minus. Overall, that's a minus for that interval, which means the particle's direction is traveling down. Okay, last one before 1, what can we pick? 0 is great. 0 minus 3 is negative. 0 minus 1 is negative. But if I multiply two negatives, I get a positive, which means my particle was traveling up. Okay, now, when you are listing your intervals, remember that we said time can never be negative. So we're going to stop the number line at 0. And we're not going to go to infinity either because they gave you a domain. What is the domain for this model? 0 to 6. So make sure that if your model has a cutoff, okay, you don't want to extend to infinity, just like you don't want to extend to negative infinity. So where was my particle traveling up? What two intervals? 0 to 1 and 3 to 6. Okay, when is my particle traveling down? 1 to 3. And on that one, it says to justify, you would put because my velocity is less than 0. Versus if I was wanting to justify traveling up, I'd say my velocity is greater than 0. So remember, velocity positive means up, velocity negative means down. Okay, the next two questions are asking you for maximums and minimums. Looking at my chart, do I see that I have a max and a min? Okay, where does the max happen at? 1, and the min happens at 3. Here's the problem. Don't write that down yet. Those are relative mins and maxes. If they want the maximum on this interval, do you remember you have to do a candidates chart? So I know that those values I found are relative mins and maxes, but I don't know until I compare with the endpoints if they're the actual biggest. So in your candidates chart, remember that you want to include your critical numbers, which are 1 and 3. But then you also want to include your endpoints, which are 0 and 6. When I do a candidates chart, what function am I plugging back into? Do you remember? Is it the derivative or the original? Original is correct. So x of t, I'm going to write it right here, is t cubed minus 6t squared plus 9t plus. Okay, so I'm going to get you calculators. So 0, you should be able to plug in without really any help, hopefully. 1, you can probably plug in. And then the easiest thing would be to type it into y equals and then just look at the chart. Yeah. Did I get everybody? You get what? Typing it into y equals.
It's pretty easy. There's like no other card. I didn't go on like a picture forever. I didn't go on. Yeah. We didn't do like 15 seconds.
What if I know that I did it? Oh, okay. Yeah, you know, it was really, I waited until the last minute, but
No.
I knew once we left for Christmas, I learned how to.
Maybe do it again, saying for close. Didn't want to.
What did you see your wife on our that way? If you put it into our feature, then you guys don't have to like. All right, let's refocus here. Okay, so the quickest way for you to do this is not to type in each number one at a time. Put the equation here and then open up your table. Zero's partner is 3. 1's partner is 7. 3's partner is 3. And 6's partner is 57. So if these are the positions on the interval, okay, if these are the positions on the number line, which one is the max position? So the max position is 57. It occurs at 6. So we're going to put max position is 57 and it occurs at time t equals 6. All right, now looking at those same values, what is the lowest on the number line that my particle is going to reach? So the min position is 3. And it occurs at times t equals 0 and 3. So you only have one minimum. The minimum is 3. It just happens twice. It would be the same as if I said the highest score was a 98. That doesn't mean only one person got that. It just means that's the lowest grade that was attained. Or sorry, highest. All right, a couple more new little random things to add in. Okay, another question that they asked on the AP test quite a bit is if your particle is traveling towards or away from the origin. In order for you to answer that question, you need to consider two things: the position and the velocity. So let's start by doing this at 0. So let's find the position at 0 and the velocity at 0. Okay, in our table, we already found the position at 0. What is the particle's position at time 0? 3 is correct. And then for the velocity at 0, I have two options. I can look at my number line, or I can just plug in 0 to the velocity function. Your velocity function was 3t squared minus 12t plus 9. But notice that wherever those t's are, I'm subbing those out with zeros. What is that number going to come out to be? Yeah, because it's going to be 0 minus 0 plus 9 is 9. Okay, so let's think about what these pieces of the puzzle tell us. If the position is 3, is my particle starting above or below the origin on the number line? Okay, it's starting above. How many above? 3. So if this is the origin, my position is 3. That means I'm starting above the origin. So let's put my particle here. My velocity is 9. Am I traveling up or down? Up. How do I know? What type of number is 9? Positive or negative? Positive. And so if my velocity is positive 9, that means that I know that my particle is traveling up. And so if I'm already above the origin and I'm traveling up, am I going towards or away? Away. Does that make sense? So you really need the combination of both. So I'm gonna put particle traveling away. Because it's above the origin and traveling up. Now, what if my velocity had come out to be -9? Then I'd still be above, but I'd be traveling which direction? Down, which would then be towards, or yeah. Okay, so that's why you really have to consider both. So now let's do the same thing at 2 for part H. Okay, first I want my position at 2. You should already have this in your calculator. Can you look up 2's partner in the table? What is 2's partner? 5. That tells me that I am above the origin. What else do I need to know? Starts with a V. The velocity at 2. Now, quick question. Let's say that I don't want to actually plug in 2. Do you remember that we made a first derivative chart that tells me which way the particle was going? So if I want to look up 2, look on your number line. 2 would be here. Would it be traveling up or down at that time? Down. So I don't know the number, but I know it's going to be negative. So I'm going to put here it's less than 0. And I'm going to put I use my first derivative test to know that. So if my velocity at 2 is less than 0, which direction is my particle moving? Traveling down. And so think about that combination. If it's above the origin, but it's also traveling down this time, then that means that it would be towards. Does that make sense? Okay. So I'll put traveling towards because it's above and traveling down. Okay. Do you feel like you kind of get that? Or what do you think? You can do it? Okay. All right, go ahead and turn the page, work through number 3. Okay, you should be able to do number 3 with your table. Give it a little shot. Yeah. Yeah, they didn't change.
Yes.
So initial mean what? So for this one, now when will you take it? They really
But they're not like the size of it, right? They're like they can't. They're useless. They don't. They always have years.
Hey, how we doing? Yeah. Now, if it's asking for initial position, initial means
I accidentally do
if I need 0, and if you want initial position, you're plugging 0 in this. So you will need the derivative, but not that. All right, ready to do number 3? Okay, I see you took the derivative. You did a great job, but if you need initial position, you just need to plug in 0. Yeah, you're not going to need that until part B. So for position, it should still be called to be x of 0 equals. So x of 0 equals, and then we're plugging in the derivative. Okay, so now let's write our interpret. So you would put at time 0. Where is the squirrel? It says you have a squirrel running around. So then would it be on the right side of the origin or the left side? So you would say the squirrel is one. All right, girls. Let's get started. Okay, so for part A, what are we doing? Okay, sometimes if you want initial position, what does that mean? You're the starting point. So you're going to take 0 and plug it in. You already have positions. Okay? -1 is correct. Now, after that, it says to interpret the meaning. So you would say at time 0, if the squirrel's position is -1, which side is on? So you would say at time 0, the squirrel is running in its negative. That would be your interpret. Yeah. I think you forgot to do it, but it would be 0 and 12 divided by 3. Alright. Silly little. So, do your interpret. If the position is negative, but it's time 0. Or is 1
and they wouldn't put a power line.
Yeah, and then just.
Okay, then when you want the direction change, derivative defines velocity. Because remember, this world can only change time. You would not want to say this is position you're plugging in 0. So then from there, we'll take out your 3 and your skill. Which means the squirrel is that so it's going to be 2 times. Say that again. And then from there, do your stack chart to see when the squirrel was running to the right versus when it was running to the left. For the right, that was to the positive velocity. To the left, you count as a negative velocity. You do good. And then remember, you're going to call your first derivative now v of t for velocity. And then set it equal to 0, find those critical numbers, and then set up your line test. Okay, we're on part B. It could be though. You went to bed at 5 for why? You don't even have a baby at home. Wait, for what? Oh, you got a long time. Why did you get that?
It's over different colors.
Why?
Both got letters. So I think why I stayed up till 6.
You did your own. No, it's like you both did your own. Didn't you say you had your own?
She had her own business.
So why didn't you stay my friend?
That was
Pay her in love.
No, that's the thing. I don't want to.
You don't accept that crazy.
The economy does not work.
Yeah, you're right, you're right. Okay. You gotta let her pay you in advertising, okay?
Advertising.
She'll let you take before and after pictures. Yeah. Huh? Is it the last question? Did you look at it? Now, we're not gonna do the next like big one. Oh, we're just gonna do the graphs at the end and then we're done. You would what?
I'd rather have a whole.
All right, look up for your parts A, B, C, D. See if you got it right. Okay, traveling to the right from 4 to infinity. Traveling to the left from 0 to 4. Okay, because V of t less than 0 for the left. Greater than 0 for the right. Okay, now, before we keep going into the next part, because I want you to keep working on your own. If you want this squirrel to be farthest to the right, think about a number line. What types of numbers would be farthest to the right? Would it be a max or a min? Think about on a number line, farthest to the right, max or min? Okay, farthest to the right is a max. And then what about farthest to the left? That would be a minimum. Okay, and now last question on those before I have you do them. If it says in the first 5 seconds, what are the end points of your interval from 0 till 5? So you should still be doing a candidates chart, but that would be on the interval 0 less than t less than 5. Okay, so they're giving it to you in kind of a tricky way, but that's the same thing as the one we just did. Okay, keep going. The sooner we finish, the sooner we can move to homework. That sounded very depressing. It's okay. Because if your velocity is less than 0, then so if you're on a horizontal number line, that would be versus if you were on a vertical number line. So for this class, you'll come in this way. So basically, just talk about the sign of velocity. Down or plus or minus. Okay, chop chop people. Okay, so then farthest to the left, we're gonna set up our candidates chart, right? What goes in the chart? Endpoints and critical numbers, right? So what are your endpoints? If it's the first 5 seconds, what are your endpoints? 0 and 5. And then what was your critical number? So it'd be 0 and 5 are your endpoints, and then 4. Now your other critical number was also 0, but you wouldn't have to list it twice. Then remember, when you plug in, you're plugging back into the original x of t function, which was t3, 6, t2, and 5. And then you're looking to see which one is the biggest for the max, which one's the smallest for the min. Good. So then what's your smallest Y value? So you would say the minimum is
Yeah.
You go to sleep at what time would you wake up? It's like wasting your whole day. That's terrible. That's like one of the nice shifts. That's
That's to be had.
So for the your way, you're on the left. Okay, so let's say and then how the velocity come, it has make that kind of nervous. Okay, so let's do the last. Plug into the position. And then you probably also have it typed in.
What's so crazy? They always tell you everything. That's why.
You never had those.
Wait, are you? So it's on the left and it's traveling to the right. You can do it the same side all the way. So that means all this Yes. Yes, it's a trick. Is it going towards or away and the velocity is 0? It's accurate, so it's not going to be the answer, but it's accurate. But the last question. No, I guess. Okay, look up there for the last few, make sure you kind of got it. Yeah, it's not really Okay, we're almost finished. Okay, for part H, can I just copy off y'all? What was x of 6? -1, and then what was v of 6? But positive 36? Okay. So then squirrel is going towards, it is on the left side, but it is traveling right. Okay. Those are your last two answers. The last thing we have to cover, we're going to skip the next word problem and we're just going to go to the graphs on the last page. Okay, so once you have those parts written down, okay, we're going to skip example 4 because it's very similar and we're going to jump to number 5 where it's a graph. And we should be able to finish these two pretty quickly and then we'll be done with notes. Okay, so for number 5, are we all good? Can I take this off? No? Yes? Because the velocity came out to be 0, that means it can't be moving towards or away because it's not moving. That was one of your critical numbers. So you good? All right. Let's finish up. Okay, so page 5 or question 5. Okay, you are looking at a velocity graph. You do not have the position. Okay, all you're given is a graph of the velocity. Okay, but remember, you now know that velocity tells you a couple different things. Okay, we know that the particle is at rest when velocity is what? Equal to 0. This is a graph of velocity. When does this graph equal 0? Okay, 1, it crosses 0. 5, where else? 8 till 10. So that last little section, it kind of stays on the x-axis. So your particle is at rest when velocity equals 0. That would be at time 1 and 5. And the interval from 8 to 10. Okay, in that sense, it's on the x-axis for like a little chunk. The particle will be traveling up when velocity is what type of number? Positive or negative? Traveling up means that velocity is positive. Where would it need to be on this graph? Above or below? Above. Do you remember doing this last semester? Okay, so where is my velocity graph in the positive values or above the x-axis? What intervals? 0 to 1 and 5 to 8. Very good. 0 to 1 union 5 to 8. Okay, when would my particle have been traveling down? What kind of velocity would I want? Less than 0 or below the x-axis. Very good. So my particle will be traveling down when my velocity is negative, which would be below the x-axis on what interval? 1 to 5. It also asks you to find relative mins and maxes. Remember, those are gonna happen at the at-rest points, which are gonna be at 1 and at 5. Let's talk about which type. Before 1, which way was the particle traveling, up or down? Because it was above, it was up, and then it switched to go down. So draw it with your finger. The particle was going up, then it was going down. Is that a min or max? Max is correct. Okay, now let's look at 5. Before 5, which way was the particle going if it's in the negatives? Down, and then it switched to go up. Draw it with your finger. It was going down, and then it switched to go up. What type is 5? Min. So let's write it out. You would have a relative max at t equals 1. Because velocity changes plus to minus. And notice this is almost the same thing we were writing back in December. We would put f prime changes plus to minus. But now we're just calling f prime velocity. Okay, then for my t equals 5, we said that's a relative min because velocity changes minus to plus. Okay, last part of that question says to find the velocity at 0. What is this a graph of? Velocity, right? So if I want the velocity at 0, I want to know at 0 what my y value is. At 0, what's my y value? 4. So put v of 0 is 4. Which way is the particle traveling? Up or down? Hold on. Don't look at the graph. Think about the velocity. It's a positive number. Which way would it have been traveling? Up. Now, the question is, if it's traveling up, does that mean it's going towards or away? What other information do I have to know to answer the question? Position. Now, if you remember when we did this unit on derivative graphs, every time you take the derivative, you lose a little bit more information. So as soon as I've taken the derivative, this can't tell me position anymore. But if you look back at the question, look at the last sentence right here, it says the particle is at position y equals -3 at time 0. So put y of 0 is -3. If that's the position, it was given in the question, because remember the graph can't tell you since it's a derivative. Where is the particle starting? Starting, is it below or above? So if it's starting below the origin and it's traveling up, is it going towards or away? Then it's going therefore towards the origin. Okay? All right. So how do we feel about that? Good? Okay. Number 6 is very similar, so we're just gonna skip and go ahead and get out your Chromebooks. Open up your Delta Math. And we are done with that.